Hey guys, do you know that nearly 2 billion people worldwide facing challenge in accessing clean water? Water filters are essential to prove clean and safe drinking water by removing dirt, chemical and other harmful microorganisms. This device ensures access to healthier water, reduce the risk of all waterborne disease and improve overall well-being. Affordable and efficient water filters are necessary in household communities and regions across the world facing challenges in the quality of water.
Unfiltered water often contains weak dirt, harmful chemical, disease-causing bacteria such as E. coli that can lead to severe health such as waterborne illness. Many filtration methods are expensive, require advanced technology or rely on electricity, making it inaccessible for people in low-income areas. Our goal was to create a low-cost, electricity-free water filter using a material that available widely.
We choose this layer design because it mimics natural water filtration in the environment where soil, sand, and organic material filter water in the river and lakes.
By designing this filter with a simple bottle and material like cotton, sand, and carbon, we make it easy to replicate anywhere. This setup is compact, portable, and doesn't rely on any external energy resources.
Here, the material we use to create the filter, they were layered in the bottle from top to the bottom. The first is optical carbon, help remove organic particles like apatite. The second is zeolite. Zeolite help to trap harmful chemicals like ammonia. And the third is fine and medium silica sand. Filter out the smaller particles like dirt and debris. The fourth is cotton. Cotton stop largest particle at the top. And the fifth is coarse silica sand. Catch the bigger apatite and support all the other layers. And number 6 is granular coconut shell activated carbon. Help to remove smell, improve taste and absorb harmful chemical. And number 7 is gauze. Keep everything together and prevent material from leaking out the bottle.
Once the layer was added to the bottle, we rinse the entire system by pouring water through it several times. This helps remove any loose dust or debris from the materials and make the filter water clearer. After assembling, the bottles were placed upside down in a cardboard stand with holes so the filter water could be collected in cups below.
In this section, we will present the result of our water filtration test, focusing on the physical, chemical and biological properties of various water samples. We evaluated the visual inspection before and after filtration, measured flow rates, turbidity levels and conducted chemical analyses such as dissolved oxygen, pH and total dissolved solids. Additionally, we assess the biological oxygen demand (BOD) to evaluate the biological contamination of the samples.
As shown in the visual inspection table, we can see clear improvements in all 3 water samples after filtration. The lake water changed from clear with an earthy odor and visible sediments to clear with no odor and no sediments. For pond water, which was initially cloudy with debris and earthy odor, becomes clear with no odor or no debris. And lastly, methylene blue, the chemical odor was removed and the water became completely clear with no visible particles. This result highlights the effectiveness of our filtration system in improving water clarity and removing odors. You can also see this visually in the picture of water before and after filtration. Next, let's look at the flow rate data we recorded for each water sample during the filtration process. For pond water, the flow rates were 0.455 ml per second for 30 ml and 0.385 ml per second for 50 ml. For the lake water, the flow rates were higher with 0.764 ml per second for 30 ml and 0.712 ml per second for 50 ml. Finally, for the methylene blue, the flow rates were slower compared to the other sample, which is 0.369 mil per second for the ml and 0.374 mil per second for 50 ml. This result shows that different types of water affect the filtration rate. To conclude, lake water flowed the fastest, likely due to its lower sediment content. Pond water was slower due to its higher debris and cloudiness, while methylene blue had the slowest flow rate, which might be because of the activated carbon in the filter worked to absorb the chemical particles, causing a slight resistance to flow. In summary, the flow rates indicate that while our filtration system is effective, the type and quality of the water influence the speed of filtration.
Before we dive into the detailed result and analysis, I would like to provide a quick review. The YSI instruments provide valuable data on the chemical properties of all water samples. The key parameters measured include turbidity, dissolved oxygen, and total dissolved solids. The table I will present summarizes the data collected, giving us a clear review of this measurement. Now, let's take a look at the result. Lake water turbidity dropped from 18.1 NTU to 10.4 NTU. Pond water turbidity decreased from 58.7 NTU to 11.5 NTU. This is the largest decrease in turbidity among the two samples. Methylene blue turbidity reduced from 52.7 NTU to 50.5 NTU. After filtration, lake water showed improvement with TO increasing from 6.58 to 6.93 mgl, pH rising from 7.04 to 7.72, and TDS decreasing significantly from 34.45 to 11.80 mgl. Pond water experienced a slight drop in DO, 7.24 to 7.11 mgl, and slight pH increase 7.25 to 7.69, but TDS sharply from 22.10 to 110.50 mgl. Methylene blue saw decrease in DO 8.22 to 7.58 mgl and pH 8.44 to 7.68, with TDS increasing significantly 24.05 to 123.50 mgl. The filtration result for lake water showed significant improvement. The result demonstrates that lake water achieved a balance similar to filtered water. Additionally, lake water performance aligns with mineral water.
After that, we just calculate and put the data in the formula 7.75 minus with 7.85 and then multiply with 300 and divide by 5. After that, we got negative 0.10 multiply with 300 divide by 5, and the final answer we got is minus 6 milligram per liter.
Our water filter effectively improves water clarity by removing dirt, organic matter, and harmful chemicals. Layers like activated coconut carbon eliminate odors and impurities, while zeolite captures toxins like ammonia. However, additional steps such as boiling or adding disinfectants are needed to ensure water is safe to consume. This project demonstrates a clean water solution can be affordable, sustainable, and easy to build. By improving the filter's compactness or testing for microbial safety, we could make this design even more practical for communities in need. That's all from us. Thank you for watching, and let's work together to make clean water accessible for all.